Students, let's discuss exercise 6.2 fifth sum. In the following figure, D is parallel to OQ and DF is parallel to OR. Show that EF is parallel to QR. See the given figure. The first condition is ED is parallel to OQ, and the next DF is parallel to OQ. We need to prove that EF is parallel to QR. Okay, so first we need to take the condition as in triangle POQ, ED is parallel to OQ. So already we know that if a line is parallel to one side of the triangle, then the ratio of the sides are equal. Okay, if line is parallel to one side of the triangle, then the intersecting line is dividing the remaining two sides in the same ratio. So here we know that PE divided by EQ equal to PD divided by DO. Okay, by basic proportionality theorem. The next condition in triangle POR. In triangle POR, we know that DF is parallel to OQ. So DF is parallel to OQ. That means PD divided by DO equal to PF divided by FR by basic proportionality theorem. So see this from 1 and 2. So from 1 and 2 we know that the right hand sides are equal. So the left hand sides are equal. PE divided by EQ equal to PF divided by FR. See this PE divided by EQ equal to PF divided by FR. Okay. So see here. If intersecting a line of a triangle is dividing two sides of a triangle in equal ratio, then the line is parallel to the third side. Okay, so EF is parallel to QR. So already we know that is converse of basic proportionality theorem. Okay, if the line is dividing any two sides of the triangle in the same ratio, then the line must be parallel to third side. Okay, so that is converse of basic proportionality theorem. So we know that EF is parallel to QR, hence proved. Students, let's discuss exercise 6.2 sixth sum. In the following figure, A, B, C are points on OP, OQ and OR respectively, such that AB is parallel to PQ and AC is parallel to PR, so that BC is parallel to QR. Okay, so this is the given diagram for the given information. So here first given AB is parallel to PQ, AC is parallel to PR. We need to prove that BC is parallel to QR. Okay, so first we need to take the triangle OPQ. Next OPR. In triangle POQ, the line AB is parallel to PQ. So we know that OA by AP equal to OB by BQ by basic proportionality theorem. And the next one, from triangle POR. The triangle POR, AC is parallel to PR. So we know that AC is parallel to PR. So OA by AP equal to OC by CR by basic proportionality theorem. So from 1 and 2 we know that the left hand sides are equal. Here OA by AP is common. Okay, so that means if left hand sides are equal, so we know that the right hand sides also equal. So OB by BQ equal to OC by CR. So see this, OB by BQ equal to OC by CR. So now we know that the line is dividing two sides in the same ratio. Okay, so already we know about that. The line is dividing any two sides of the triangle in the same ratio, then the line must be parallel to the third side. So that is converse of basic proportionality theorem. Okay, so we know that BC is parallel to QR. Actually, this only we need to prove that. We proved. So BC is parallel to QR, hence proved. Students, let's discuss exercise 6.2 seventh sum. Using basic proportionality theorem, prove that a line drawn through the midpoints of one side of a triangle parallel to another side bisect the third side. So recall that you have proved it in class 9. So here consider the given line L. Okay, L drawn through midpoint P of line segment AB. Actually, that is only given. Okay, a line drawn through the midpoint P of line segment AB. Actually, this point is midpoint of the line segment AB. So meeting AC at Q. Just we extend the line. Okay. So this line is parallel to BC. So this line LSPQ is parallel to BC. If the line is parallel to any one side of the triangle means we know that the ratio of remaining two sides are equal. Okay, so we know that AQ by QC equal to AP by BP. So AQ by QC equal to AP by BP. At the same time, already we know that P is the midpoint. So that means AP equal to BP. Okay, for example, AP is 2, then BP is also 2. Then AP is 6 and BP is also 6. Okay, if we are taking any value, for example, 5 divided by 5, because that is midpoint. So we'll be get 1 divided by 1. We can simplify. So for that purpose only directly we took. Okay, so 1 divided by 1. So the ratio is 1 is to 1. So AQ by QC equal to 1 by 1. So therefore AQ equal to QC, or we can say that Q is the midpoint of AC. Actually that only we need to prove here. Here we proved Q is the midpoint of AC. Here Q is the midpoint of side AC. This Q is dividing third side of the triangle into two equal halves. Okay, so that is only here we need to prove Q is the midpoint of the third side AC.